Hello everyone, I will be presenting the work DISSIMILAR towards fake news detection using information hiding, signal processing and machine learning. This is David Megias from the Universitat Oberta de Catalunya, and this is a joint work with Minoru Kuribayashi from Okayama University in Japan, Andrea Rosales, also in the Universitat Oberta de Catalunya, and Wojciech Mazurczyk from the Warsaw University of Technology. The outline of the presentation is the following. I will start with an introduction. After that, I will provide a brief overview of the technologies that will be used in the DISSIMILAR project. Then I will present the project design. After that, I will introduce the methodology and architecture of the proposed system. Then I will provide a brief overview of the expected impact of the project, and I will conclude with a summary and the future work for the DISSIMILAR project. So let me start with introduction. Well, as you already know, fake news is one of the main problems, one of the main issues nowadays in online social platforms. Online opinion leaders have an influence on online communities, and this sometimes entails building on fake news. And the spread of rumors and the dissemination of fake news have been reinforced with the increasing relevance of online social networks and the popularization of the participatory culture. In this project, we pretend to use digital watermarking. Digital watermarking is recognized as a promising technique developed to address the problems of copyright protection, content authentication, or tamper detection, among others. And the application of digital watermarking techniques could be beneficial for fake news detection, identification, and tracing, and such a concept has not been so far researched in the existing literature. The existing works for detecting fake videos are focused on finding imperceptible characteristics that appear in the forged videos using machine learning that is very similar as the state analysis techniques, but novel and more effective solutions for detecting deepfakes are required. In addition, cross-cultural factors and the user experience should be taken into account when designing such solutions that may be integrated into social media platforms. So this is an overview of the DISSIMILAR project. In the DISSIMILAR project, we will be using an interdisciplinary approach combining different methodologies, techniques, and disciplines, including digital watermarking, machine learning, and the user experience. It is also an international setting with a cross-cultural approach, including analysis of users in 3 different countries, Poland, Japan, and Catalonia, Spain. And it will also have a multilingual focus with at least 4 languages, including Spanish and Catalan, Polish and Japanese. And it will be considering different media formats, including video, images, and speech and audio. Now let me present a brief overview of the technologies that we will be using to deal with the fake news problem. The first technology we plan to use is digital watermarking. As you already know, among the applications of digital watermarking, we have proof of ownership and owner identification. For example, we also have transaction tracking and tampering detection, and these are the areas more relevant for the DISSIMILAR project. This will require a combination of different approaches, including robust watermarks for proof of ownership or transaction tracking, but also we will need the use of fragile or semi-fragile watermarks for tampering detection and localization, and this is quite a novel scenario in which different types of watermarks are involved and this represents a diversity of requirements and more complexity compared to traditional digital watermarking applications. In addition, we will be considering different types of multimedia content, including image, audio, and video. The second technology that will be involved in this project is multimedia forensics. In multimedia forensics, the idea is to develop solutions to reveal the history of the contents, including the identification of the acquisition device, for example, a camera, the validation of the integrity of the contents, and the retrieval of information from the signals in the contents. As you may know, an acquisition device leaves some specific traces due to its intrinsic characteristics, and this is referred to hardware-oriented distortion. Also, some tampering applications of multimedia contents leave distortions in the media caused by the signal processing operation in software, and this is usually called software-oriented distortion. And with the assistance of the learning techniques, we can detect these kind of distortions and classify malicious editing traces in multimedia contents. And the third collection of techniques that we will use in the project is machine learning detection tools that will be used for the classification of fake contents, and this involves, on the one hand, extracting features from a target content that we want to classify, and then to calculate a metric using a machine learning algorithm and determine whether the feature belongs to a positive or a negative class. In this process, there are two steps, one step for feature extraction and another step for feature selection. And we plan to use deep learning in such a way that feature extraction can be carried out automatically, which will be more efficient. Regarding the machine learning algorithm for classification, nowadays recurrent neural networks and convolutional neural networks are the basis of many techniques, and several solutions have already been proposed for the detection of artificially generated faces and voice. Now let me present the design of the project. The project involves two main areas. On the one hand, we have digital watermarking and detection tools, and on the other hand, we have the user experience study. Regarding digital watermarking, there is a set of specific objectives that are given in this slide. The first one is the selection of suitable digital watermarking techniques, then the design of the architecture of the proposed system. Also, we plan to design and develop automatic and easy to use digital content verification mechanisms with a user warning feature if fake news is detected. Then we will design and develop a mechanism for identifying the origin of the fake content propagation, and this will conclude with the development of a proof of concept implementation of the complete system. As detection tools are concerned, the approach is similar. First, we need to extract feature vectors from suspicious multimedia contents. Then we will design artificial neural network solutions for classification. Then we will need a collection of data sets for training the proposed system. And we plan to develop a compact and efficient implementation of the machine learning classification. And in the end, we will also conclude with the development of a proof of concept implementation of the complete system. Regarding the user experience study, there are two main goals here. The first one is to identify the cultural factors that should be taken into account in the design of the system, and the second one is to analyze the best way to offer the technological tools to the users, to the subjects, and this will involve cultural comparative research involving 3 different countries, Poland, Japan, and Spain, and this will contribute to the iterative prototyping process. The particular objectives of this user experience study are to identify the cultural factors that should be considered in the design of the tools. Second, to take critically informed decisions for the design of the tools. And finally, evaluate the potential impact of the system. Now let me present an overview of the methodology and architecture of this project. As methodology is concerned, the project will be divided into 3 different phases. The phase 1 is the design and implementation of watermarking tools. In this phase, we will select and implement watermarking solutions to create a proof of concept system that will be evaluated empirically. Regarding phase 2, this consists on designing and implementing detection tools. These detection tools are based on deep neural networks that will be used for the identification of fake contents. And the third one is the user experience study. In this phase, we will be deploying focus groups for a better understanding of the cultural factors involved in the dissemination of fake news, and we will conduct heuristic evaluation and usability tests, combining qualitative and quantitative data for the iterative prototyping of the tool. Now, as the architecture of the project is concerned, this picture provides an overview of the whole architecture. First, we can distinguish content producers, that are the ones that will post or publish media in an online social media platform, and on the other hand, we have content consumers that will receive these contents. In the system, we plan to use forensic tools to evaluate whether the digital media are manipulated or not. And then watermarking tools will be useful to provide a digital stamp on the introduced content. On the content consumer side, we have machine learning based detection tools to allow users to determine the authenticity of the received content. And all those tools will be designed and developed taking into account the results of the multinational user experience study. Now let me provide an overview of the expected impact of the project. The expected impact of the DISSIMILAR project is threefold. For online social media users, we plan to create tools to distinguish between original and altered media content, and this will help to enhance the credibility of legitimate news and original content, and at the same time to minimize the negative effects of fake news. For content producers, tracking authorship in the creation and potentially the transformation of digital content is a valuable solution, and digital watermarking will help to counter untrackable content generation or modification. This kind of watermarks may prevent a given content producer having to deal with image or trust issues due to fake content attributed to them. Finally, regarding the scientific community, we expect to produce a collection of publications contributing to different technical areas, including digital watermarking, media forensics, signal processing, and machine learning-based detection tool, among others. Also, the user experience study in an international, multilingual, and cross-cultural environment will help understand the social aspects related to fake news and their distribution, and this is quite a novel interdisciplinary approach that combines techniques from different areas and also taking the perspective from the social sciences. Now let me conclude with a summary and the future work for this project. DISSIMILAR is an ongoing international project carried out by 3 partners from Poland, Japan, and Spain. The main aim is to develop tools based on digital watermarking and machine learning that will allow the detection of fake news in social media platforms. And also a user experience study will be conducted to provide implications for the design, implementation, integration, and evaluation of the tools based on the experiences of diverse potential users. We also aim at attracting more research from different academic communities to face the challenge of reducing the impact and redistribution of fake news. So new research is welcome in these areas, and we plan to provide the possibility of introducing these new solutions to our prototype. We propose an interdisciplinary strategy to face the problem, including data hiding, machine learning, multimedia forensic, and also taking into account social and cultural issues. And in the end, we will have a prototype combining all these tools and the knowledge on the user's behavior that is expected to be more successful than partial solutions on their own. So this is all for my presentation. Thank you very much for your attention, and now I will be happy to answer some of your questions. Thank you very much.